So we're continuing on our journey here of linear equations and specifically linear equations in two variables. As you saw in the last unit, when we solved equations, each equation had only one distinct variable and we were able to get a single answer, unless we had the special situation of infinitely many solutions or no solutions. Today we're going to deal with equations in two variables. An equation in two variables is an equation that contains and pardon me for a moment, just want to make sure my stuff is plugged in. Okay, good. An equation that contains two different variables. And you should be able to guess that those two variables will usually be x and y. Because why? We're graphing, and we have an x and a y coordinate. The solution of an equation in two variables is an ordered pair, or a point, or points, x, y, that produces a true statement when the values of x and y are substituted into the equation. Okay. Finally, a linear equation, and you can see built into the word linear is the word line, is an equation whose graph is a line. All right, so let's go through our steps here. We're going to learn three ways to graph a linear equation. The first one that we're going to do today is graphing where we create a table of values. It's not the most efficient way to do it, but it is helpful to know how to do it, and it is used when we graph other types of shapes. Okay. The other thing is the other two ways you're going to learn are more efficient and easier to deal with. But like anything, the more different ways you learn how to do something, the better off you are. So the first thing we need to do is we need to write the equation in y equals form, meaning we want to isolate the y, which is called slope-intercept form. Okay, now this concept of slope-intercept form, which you're going to see later on in this unit, is very, very useful in graphing. Now, since we're using a table of values, we're going to make a table of values by choosing values for x. Now, why are we choosing values for x? Because x is our input. So x is the numbers that we want to input and substitute each value into the equation to get corresponding y value, which is our output. Lastly, we're going to plot the points and make sure they form a line. Now, if they do not form a line, then you've got to, one, check your math, 2, check your plotting. All right. So I want to know if 5, negative 1 is a solution. Well, 5 is my x, negative 1 is my y. So all I'm going to do is in place of x, put 5. In place of y, put negative 1. And now I have a numerical statement that I can evaluate under order of operations. I have a double negative, so that becomes plus. So is it a solution? Yes. And what that means is the point 5, negative 1 lies on the line that is created by the equation x minus 3y equals 8. All right, so let's now see how we do this table of values. All right, my equation is y equals 2x plus 1, and I'm telling you the 5 specific y values to use. All right, I mean x values to use, I'm sorry. And I can tell you them to use. You can choose your own. The reason I tell you is that we're all then using the same values. All right. Sometimes some numbers are preferable to others. The key is we don't want to choose numbers that are going to give us very large values so that they're going to be difficult to graph. So all this means is in place of x, I'm going to put in these 5 values and evaluate what I get. So in other words, I'm inputting 5 different values for x, and I'm going to calculate my output. What's my output? Now, if you notice, and it's not a coincidence, my x values are going up by 1 each time, and my y values are going up by 2 each time. That's called a constant rate of change. And a constant rate of change needs to exist to be able to have a linear equation and a line. So now I plot my points. And lo and behold, they connect to a straight line. Please make sure when you graph a line that you put arrows on the end. Okay? Now, I want to solve this equation by getting y all by itself. Well, what's attached to y? A negative 4x. So now I just add 4x. Those cancel. And now I have y by itself. Now, you might be saying, well, why do I need to do that? And the reason is when y is put by itself, it makes it easier to do the calculation with this input-output concept. In other words, it's much easier to put x, a value in for x here, and get y than to do it in this equation here. So this equation is much easier to work with. And as you'll see as we go later into this unit, an equation in this form is very, very useful. All right. Is 3, 2 a solution? I put 3 in for x, 2 in for y, and do the math. And the answer is no. So that means the point 3, 2 does not lie on the line that is the result of 2x minus y equals 5. Next one, I want to solve for y. And it helps to write the original equation correctly. So I want to get rid of that 3x. Now, hopefully you're seeing what gets carried down as negative y equals negative 3x plus 7. If you remember back to when we were solving equations, we don't like our variable to be negative. So the way we can change that is to multiply everything by negative 1 so that we get y equals 3x minus 7. All right, which one is the solution? Where people are getting mixed up, the first number is x, the second number is y, while this goes yx. So the answer, which is A, is because 2 times 13 minus 3 times 6 is equal to 18, or 26 is equal to 8. I'm sorry, jumping ahead there. Or 26 minus 18 equals 8. All right, so don't mix up your ordered pair. Finally, we want to graph y equals 3x minus 2. Again, we're going to use these 5 coordinates. Again, we're going to put these numbers in for x, You could see why creating a table of values is not the most advantageous because it does require a bit more work. And when I do this, now you'll see again the pattern. I'm going up by 1. I'm going up by 3. Okay? There's my constant rate of change. I'm going to plot the 5 points. And one of the things, as we talked about in class, is that we technically only need 2 points to graph a line. But by putting more points there, it ensures that what we did mathematically is correct. So in other words, if I couldn't connect all of these points by a straight line, then I did either something wrong in the math in my table, or I did something incorrect when I plotted the points.